So guys, we are looking at the uses of the mass spectrometer. The uses of the mass spectrometer. Now, one, we had earlier on said that it is used in determining relative atomic mass. Now, it has various uses. One, it is used to determine, the relative, atomic mass of isotopes. Two, it is used to detect labeled atoms. It is also used to determine the relative molecular mass. This is determine the molecular mass of compounds. It can also be used to determine ionization energy, and these determine ionization energy. So all these are uses. In fact, another use, it is used to determine the relative atomic mass of isotopes. And the reason we trust it is that the mass spectrum is very accurate. It is very accurate. Now, having looked at the uses of the mass spectrometer, let's look at these uses in a more practical example. Let's see how do we interpret a mass spectrum of a given element, and then we come up with a conclusion. So let me get an example from here. The question says that when chlorine was analyzed, the following spectrum was obtained. The following spectrum was obtained. The following spectrum was obtained. Now, let's look at the spectrum which was obtained. Let's look at the spectrum which was obtained. We say on the spectrum it is a plot of percentage abundance. It can be relative intensity, and we said it is percentage abundance against isotopic mass. So this spectrum had a peak of abundance 75 corresponding to chlorine 35. Then it also had another peak at 25 corresponding to chlorine 37. Now, we must make sure that these peaks correspond to the percentage abundances that we talked about. Okay? Now, we said that the way of doing this is pretty much easier. We said that we haven't asked the question. So the question is, when chlorine was analyzed, the following spectrum was obtained. So the question was, explain the spectrum. Question, explain the spectrum and use it to calculate the relative atomic mass, of chlorine. So, let us be careful now. How do we explain this spectrum? Okay? Now, when you look at our spectrum or graph, it is a plot of percentage abundance against isotopic mass. Now, we know that chlorine is isotopic or exhibits isotopy, and we did say isotopy is the existence of an element having the same atomic number but different mass numbers due to different number of neutrons. Now, how do we explain this spectrum? The explanation is very simple. One, we are going to say that chlorine is isotopic. Chlorine is isotopic, i.e., it has two isotopes. It has two isotopes. That is chlorine 35 and chlorine 37. Okay? We go ahead and say that the percentage abundance of chlorine, the percentage abundance of chlorine 35 is 75%, and that of chlorine 37 being 25%. There we have explained the spectrum. This spectrum shows us that chlorine has two isotopes, that is chlorine 35 and chlorine 37. So the percentage abundance of each of the isotopes, chlorine 35 is 75% abundant, and chlorine 37 is 25% abundant. But what does this mean? It means that if we had an isotope, if we had a chlorine atom and the two are present, then out of that, 25% is chlorine 35 and 35% would be chlorine 30. 75 is chlorine 35, then 25% is chlorine 37. Now the next thing they said, we use it to calculate the relative atomic mass of chlorine. Now, we know that relative atomic mass is summation of percentage abundance summation of percentage abundance times isotopic mass times isotopic mass. Now, we substitute in our formula that we had earlier on. The formula was of this nature, that it is percentage abundance, that is 75, times isotopic mass, which is 35, plus percentage abundance of chlorine 37, this is 25 times 37 bracket. So the whole of this can be made divided by 100 according to our previous formula. Now, when you press your calculator, you realize that this is 35.5 and this is the relative atomic mass of chlorine. That is the known value that we even have in the periodic table. If I can refer you there, we will get the same thing. So let's meet in the next example. Thank you.